Hello everyone, welcome to COMP125. Um, this week and the following week we are going to cover chapter 2, which is going to focus on designing algorithms, how we can actually write down an algorithm for a computer in terms of actually pseudocode, not in terms of some programming languages that you can running it on a computer, but how we can write down, how we can solve a problem, write down an algorithm for that. We are going to actually learn about a different type of a statement, like the sequential statements, conditional and iterative statements, that with the combination of all of these allows us to write down very complicated algorithms, and we will see plenty of examples. So before I actually jump into the writing our pseudocode and first algorithm, I would like to just give a brief recap about what we have actually learned in previous week about the computers. So in general, a computer is going to be a combination of a set of hardwares and softwares. What are the hardwares? Basically, we have 5 different components in a computer. Some input devices, which basically gives the information to the computer from the user. Any device that get some information from the user and pass it to the computer is going to be an input device. For example, your keyboard, the mouse, the microphone, if you are scanning some images, all of these are going to be some input devices. We are going to have some output devices in a computer, because computer is going to do some processing and then show the results to us. This can be the monitor of your computer, the speaker. If you are printing something, the printer can be actually an output device. And the next actually important hardware component, is going to be the CPU. You can think of a CPU basically as the brain of the computer, which does all of the processing. Later on during this course, we will learn that computers actually just can do very simple instructions, but we write that complicated algorithms, which is just a sequence of all of these very simple instructions, and using that we can solve very complicated problems. And the other main components are going to be the main memory, which we call it RAM. So the main memory is going to be, the piece of the memory that CPU has access to that, and it's just like, a scratch paper for the CPU. When the CPU is doing those computation, the data that the CPU is working on has been saved on the RAM. And we will learn that, for example, the RAM has been divided to some small cells. Each cell is going to be called 1 byte, which itself will be divided to 8 bits. Each bit will be just a 0 or 1. And except that, we also need some secondary memory, it's going to be the hard drive of your computer, that the information will be stored there permanently. So RAM is not going to keep the information. Whenever you turn off your computer, every information on the RAM is going to be erased. So it is a hardware. So basically now you can understand that not only your, for example, your desktop, your laptop is going to be a computer, but also if you have a tablet, an iPad, your smartphone, basically all of these devices are going to be a complete computer. It has all of these 5 different components. The other parts of a computer, actually, which we are going to focus on mainly in the following 3 or 4 weeks is going to be the software, which is going to be a set of computer programs. So all of those computer programs are going to be some algorithms that has been written in the language of the computer. Computer can understand that language. And it is going to be a combination of those algorithms and some data that the algorithm will be executed on that data. So the combination of these two is going to be the whole program that the computer will execute, and this is just the whole purpose of a computer. So if we think of it in a in terms of some some cooking analogy, we can see that the data can be all of the ingredients, for example, that you are using for cooking, and the algorithm is going to be the recipe that you follow. The computer is going to be someone, it's just like a cook who follow the instruction, that recipe, execute all of those instructions over the data, and so the result is going to be a cake that the user will use it. Okay, just before I will continue, these are some questions, some basically fun questions for you, that in cooking analogy, which one is going to be corresponding to the recipe? Okay, the recipe is that set of instructions that we follow, so it's just like it's going to be the algorithm. What is going to be the ingredients? The ingredients in terms of the computer science, it's going to be the data. Which one is going to be corresponding to the cook? So we can see that the computer is going to be the cook, because it's the one who follow the instructions and apply that over the data and execute them. So, and who is going to be the one who write the recipe? It's going to be, of course, this time it's going to be the programmer. If we are a programmer, if we write some algorithm for the computer, so it's just like we are writing the recipe. Okay, so the whole idea of the computer science basically is problem solving. You, as a computer scientist, you are going to learn how to solve the problems. This is the most important skill that you need to learn to be a computer scientist or a programmer, a developer. So problem solving is going to be the ability of formulating a problem. You get the statement of a problem. You need to formulate this problem, find an algorithm to solve the problem, and then write down your algorithm in terms of a sequence of clear, precise, and unambiguous instructions for the computer. If you do that, your algorithm would be something that we can actually give to the computer and make it automated. So if we wanted to write down an algorithm for the computer to understand, we need to write down this algorithm in terms of some languages which is understandable for the computer. It's just like the way that we talk to someone. We need to talk to the language that he or she understands. Otherwise, we cannot actually communicate. Just like that, when you are writing something for the computer, it needs to be written in terms of a language which the computer understands. Usually, we write our programs or algorithms for this is something that we are not going to learn in this course. I'm just going to show you the process. So the high-level programming languages actually are going to be those languages that the programmers, developers usually work on. For example, Java, Python, C++, C#, all of these are going to be high-level programming languages. High-level programming languages are basically easy for us as humans to understand, And basically someone has basically written some compiler that these high-level programming languages will be translated to the language that the machine can understand. But these high-level programming languages basically cannot be understood by the computer directly. What would happen is these high-level programming languages needs to be compiled and translated to some low-level programming languages, which is called, we mostly call them assembly language or machine-level language. So basically, the assembly language is something like this, which basically means that subtract B from C and store it in, for example, D. This is, I don't want you to, memorize this kind of stuff. I'm just giving some example to you that what we mean by assembly language. But I don't expect you to memorize this as a part of this lecture. So then this assembly language will be directly actually transferred and translated to some binary language that you can assume it would be something like this. This is not going to be, of course, correct in terms of some computers. You can just assume that this is going to be translated to something like this. So, and this is, as I mentioned, this is going to be the task of a compiler. Programming languages, the high-level programming languages have two different type of programs to translate the program that you write in to the language that the computer can understand. Some of those programs are going to be called interpreters. Some of them are going to be called a compiler. Interpreter and compiler are very similar to each other in terms of this fact that they get some source code, which is going to be a program, an algorithm that you have written in terms of some high-level programming language. And then you pass it to your interpreter or to your compiler. And the purpose of both of them is to just translate it to some language that the computer can understand. The difference between an interpreter and a compiler is that in the interpreter, the interpreter actually just translate the source code, the program line by line, but the compiler translate the whole file once. So you pass the whole file and it just translates everything and just return another file that we usually call it an object code. This is something that can be executed by the computer. So here is just a review question again, some fun question for you. What is the difference between a high-level programming language and a low-level programming language? We say that a program is high level if you are standing and low level if you are sitting. B, it is high level if you are programming for a computer, and low level if you are programming for a phone or a mobile device. It is high level if the program must be processed before it can be run, and low level if the computer can execute it without additional processing. And it says it is high level if it is easy to program and short, and low level if it is really hard to program and it is very long. Basically, of course, the C is going to be the correct answer here. High-level programming languages, high-level programs are going to be those programs that you need to process them. Either you need to pass it to a compiler or to an interpreter, and it needs some processing to be able to be executed on the computer. And low-level programming languages are going to be those ones that the computer can understand directly and it doesn't need additional processing. The other actually options that you had here, some of them are basically just for fun, and this one you might actually be curious that maybe this one is correct. but this is just the properties of the languages that will be written in high level and low level. Of course, when you are writing in high level programming languages, it's going to be much easier, so it's going to be much shorter usually than those programs that you write in low level programming languages, but the correct answer is going to be C. Okay, so that was just, a general overview of what would happen when you write down an algorithm and you write down a program. From now on, I'm going to just try to show you how we can write a program. Not actually a program, but basically, because this course is not about learning a programming language, we are going to just give you an overview, as the name of the textbook also says. It's going to be an invitation to computer science. So I'm going to just give you an overview of all different aspects of computer science. So here I'm going to show you how we can write down some algorithms, not actual programs written in terms of some programming languages. So we are going to first start with a very simple program. I am going to write down an algorithm to compute the balance of your account, for example. How can we compute the account balance? Assume that, we know that the balance is going to be equal to the amount of debt in your account, the amount of debit in your account, not debt, minus the credit that you have already actually used as your in your credit card, for example. Okay, so this is going to be very simple for us. If I wanted to write down an algorithm for this, if I'm going to execute and calculate the balance for my account, I just need to subtract the amount of credit from the amount of debit, right? But I wanted to write down an algorithm, something that can be understood later on, can be actually translated to a language that computer can understand. So we need to, remember what we have discussed last week, that the set of instructions, the algorithm that you give to the computer to execute it, needs to be just a set of primitive instructions. For example, add something to something else, subtract something from something else, get something from the input, print something in the output. So some simple instructions, and everything should be unambiguous. The computer needs to be able to execute all of those actually instructions. Nothing should be unclear here. But you should always memorize this fact that when you are writing something for the computer doesn't know anything basically. So it's just like, a very stupid person that doesn't have any information. You should actually assume that it's not a human. It is a machine that doesn't know anything, and you are the one who has to give all of the information and all of the instructions to the computer, and it just actually can execute the set of instructions that you pass to. So for this simple problem that we have, the algorithm that you might come to hand is something like this, that give a value of debit and value of credit to the computer, then subtract credit from the debit, and then print the value. Okay, this is something that you write for a human, not something that you can actually give to the computer. It is ambiguous. The computer doesn't know what is debit, what is the credit, where are they? Where are all of these information have been written? Okay, so we need to, instead of writing our algorithm in this way, write down in terms of, shorter instructions, that each of them is very clear that what needs to be done. So we call it actually a pseudocode. A pseudocode, what we have actually previously written, has been written in terms of English, and it is completely clear for us, for me and you to understand, but it is not clear for the computer. It's just a long, sentence. Get these values, subtract them, and then print them. Okay, computer cannot understand them. You need to give short and clear instructions, step-by-step instructions to the computer. Because we don't know any actual programming language, we are here going to use a different language that we call it a pseudocode. This is going to be something similar to kind of a high-level programming language, but still this is something usually between the natural language and a high-level programming language. We call it a pseudocode. I'm going to show you some example of a pseudocode. For example, a pseudocode that we can write for this algorithm. So I'm going to basically break down this long sentence, which has many different actually steps, to a short, the one with some steps, and each step is going to be, something clear for the computer. Get the value of debit to the computer. Give the value of debit to the computer. Give the value of credit to the computer. Tell the computer to subtract credit from the debit and store it somewhere. And then tell the computer to print the value which has been calculated in the previous step. So now, instead of writing down just, a long sentence with a lot of actually different information, now I have break it down to a couple of steps that, it's much better than the previous algorithm that I have written. But still, there are some issues here. When you are actually saying subtract credit from debit and store it somewhere where this information is going to be stored. Give the value of debit to the computer where the computer needs to actually store this debit or credit. Computer doesn't know anything, just always remember that. So now you can actually see that this is the data that your algorithm is going to work on. The data is going to be the value of debit that you are passing, the value of credit that you are passing, right? So these are going to be the data, kind of the input to your algorithm, right? This is something that you need to give to the computer, and the computer needs to store them somewhere because computer is going to work with them, right? And then after computer actually is working with that, still the computer needs to have access to somewhere to store the result of this calculation in step 3, right? So this is where we actually come to this important actually basics of writing any piece of code or any algorithms. When you are writing any algorithm, we have 3 main building blocks. We have values. This is going to be different type of data that you are working on. We have variables. Variables are going to be, I'm going to actually define it, but this is going to be some space in the memory that you store the values. And when you are writing your algorithm, you are working on that data. So basically you are working with the variables. And at the end, a set of operations. So all of those instructions that you write. So now I'm going to give you some intro that about what are these different values, data types that we are working on, how we work with the variables, and then we will come back and complete this algorithm and write down a better pseudocode for this algorithm, for this actual problem. So different, values and the different data types. Basically, when you are writing a program, your program is going to work on some data. If you are not working on some data, you basically don't need a program at all. Always the computer is working on some data. This data can be anything. It can be just one letter, it can be a string, a sequence of letters, it can be an integer number, it can be a floating point number. So we have different type of data. All of these values, this data that you are working on, or can be actually in one of these simple types that we have discussed here. Of course, for example, an image, a soundtrack, all of these are going to be data. All of them can be something that you pass to the computer and write down some algorithm to work on. But those examples that we focus on in this chapter are going to be only some numbers or some strings. So I'm going to just simplify the examples in this course. We are not going to learn about a very complicated algorithms, of course. So you can have just some single values that you are work on, or sometimes you need to work on a list of values, a sequence of values. For example, you have this sequence of values that next week we are going to learn about them. In this course we are going to, for example, show them that a list of values like, for example, A1 and then A2, A3. Okay, so for example, A1 can be the value 2, A2 can be 4, this can be 10, something. So it's just showing you that this is a list of values. So these values, this data needs to be stored somewhere. Computer is not like a human that you just tell him that, okay, this is a number, and you as human still you have some memory. You keep these values that I'm telling to you. You keep them in your memory, right? So just like that, the computer needs to store this information somewhere. But computer doesn't even know that it needs to store it in the memory. So you need to directly tell the computer that, okay, save this value in this part of the memory as this name. Okay, as I told you, computers are not like humans. They are just a stupid machine that doesn't know anything. So you should think about variables as just like some space in the memory that some value has been written there. But because we can't actually directly address which part of the memory we are referring to, we give them some name. Those names are called the variable names. So for example, in this example that I've shown to you here, I can have a variable like you call it Z, and it is just like an address in the memory that you have stored some value that value is going to be 15, for example. Another variable like Y that is referring to some part of the memory, and it has stored some value that that value is going to be 5, or here another variable X that has the value 10. Okay, so now the last actually part that I need to, when we are basically working with some variables, the simplest instruction, the simplest operation instruction that you can write down for the computer is that you tell the computer, for example, to store this information in the variable like with this name. Okay, in this way you it's just like you can work on some data in the computer. So when I'm actually saying a statement, basically I mean a statement for the computer is going to be the smallest instruction that you can tell the computer, and the computer can execute them. And those statements that works on the variables, for example, as you are actually telling to store something as a specific some value as a specific variable, this is going to be an assignment statement. So we usually in the pseudocodes we write it in this way, that set balance, for example, to 32. You can see that this statement has basically two parts. It means that I need to have a variable that the name of the variable is going to be balanced, and I am assigning 32 to that. So you are creating a variable, you call it balance, and you store the value 32 inside that variable. Okay, so in this way, we can actually work on some data. If you wanted to work on some data, as the, for example, balance of your account or debit of your account, you can define a couple of variables, assign some value to them, and then later on work with them. Okay, so here is just showing you a couple of different type of assignment statement that we can write. I'm actually giving you these examples because later on we are going to come back, go back and rewrite that pseudocode for calculating the account balance. Not only you can write down some specific values as the name of the variable, but also you can, for example, copy from some other variable. For example, you have a variable called balance, and it has some value, and then you wanted to copy whatever is the value of balance inside another variable. In this way, you are just basically get the value of balance and copy it inside the variable my saving. Or for example, you can write down a statement like this. In this way, the computer first compute this value, acceleration multiplied by time, divide it by 2, first calculate this, and whatever will be the result, it will be stored in the variable called dist. You can see here that acceleration and time, both of them are going to be some other variable, and they are going to have some values, right? And so the computer basically will read the value of these from the memory, calculate this expression, and get the result and store it in the variable dist. So we can write all of these different statements basically. So let me now go back and rewrite this algorithm for us. Remember, we have written this algorithm, okay? Now we can basically write down this example in a better way. When you are saying that give the value of the bit to the computer, okay, so you wanted to write something for the computer. Not exactly for the computer, but something that you can directly translate it to some programming language. Now here I have actually written some better pseudocode for our algorithm. That the first actually line has been translated to, I have actually written it as get the value for debit. So now you can actually know that I have defined some variable called debit, and the value of debit will be, you can just think it in this way, that you as a user of the program will pass this information to the computer. So for the computer, it's just like the computer knows that I should get the value from the user. So I will write it in this way, get a value for the debit. Okay, so it basically means that the computer will ask the user to enter the value, and then it will store it in the variable called debit. It will ask for the value of the credit and store it in a variable called the credit. And then it calculates the value of balance. What is going to be balance? It's going to be debit minus credit. Now you can actually see that this statement that I have written here that tell the computer to subtract credit from debit and store it somewhere. What is going to be that somewhere? I have defined a variable, I called it balance, and tell the computer to execute this line, set balance to debit minus credit. So computer will basically understand that it should subtract credit minus debit, get the value, and store it in a variable balance. Then that value can be actually print, and this statement here will print that value. So now this is a pseudocode that that is acceptable whenever I'm actually asking you to write down an algorithm for for a problem. I would expect you to write down something similar to this. Okay, now let me actually go back and show you some examples about the statement variables. Okay, so I have actually written some examples for you. Assume that we have written some algorithm like this. What will be the value of the variable small and big after you execute all of these instructions? So as you can see, whenever you have an algorithm, basically it's just a sequence of instructions, right? You have to read them from the top to bottom, execute them one by one, and then after that actually you will realize that what would happen to for example, if it is printing something, if like this question I am asking that what is going to be the value of a small or value of big, you will actually understand that. So it's just like you are I'm asking you to try to simulate that if you give this algorithm to a computer, what will be inside the variable small and inside the variable big at the end. It's just like you are trying to simulate the way that the computer reads this pseudocode, and we call it you trace the algorithm. So the first instruction that will be executed is that you set big to 10. When you are actually tracing an algorithm, the easiest way to trace the algorithm is just like you create a table, and in this table you create one column for each of the variables that you have. For example, big here and a small. I don't have anything else. And then I will try to just read the instructions, follow the instructions, and say that what would actually be the value that will be written inside each of the variables that I have. So here in the first step, you will set the value 10 to the variable big. So it's just like the value of big now is going to be 10. I still don't know what is the value of a small. In the next step, the instruction, the pseudocode tells me to set a small to 20. So in the next step, the value of big hasn't been touched, so it's going to be 10 yet. But the value of a small now is going to be set to 20. Okay? When I'm reading the next instruction, I will understand that it's just telling me that to set big to a small. Okay? So it's just like you are getting the value of a small and writing it inside the variable big. So whatever is inside a small, you are copying it. It's just like you are copying this value inside the variable big. So big is going to be 20 and a small is going to be 20 as well, right? Because you haven't changed a small. And you are done. There is no other instruction here to be executed. So now I can just look at my table and understand that, okay, the value of big is going to be 20, and the value of a small is going to be 20 as well. So the answer here is going to be D, right? The value of big is 10 and the value of a small is also 20, both of them. Let's actually do another example. Here I have 4 instructions. Again, what I will do is that I will draw a table. I will draw one column for each of the variables. In total, I have 2 variables. One of them is m, the other one is n. At first, I don't know what is the value of, basically you don't know what is the value of m and n. Nothing has been set. Then just execute the first line. By reading the first line, you will understand that you should set m to 10. So m will be 10. Then by reading the second line, you will understand that you should set n to 20. And what is the value of m? No, the value of m is going to be 10. I haven't actually changed that, right? In the next line, you set m to n. So basically, it's just like you are copying the value of n, whatever is the value of n, inside m. So 20 will be written inside the variable m. And whenever you are actually just writing something inside a variable, the previous value is gone. So actually this value is gone. You don't have it anymore. The value of m is going to be 20. And the value of n will not be changed. So whatever it was before, it's going to be just like that. Now, in the last line, you are copying the value of m inside n. So what is the value of m now? You can see that the value of m, the value of m is 20. So whatever will be written inside n is going to be 20. It's just like the value of n hasn't been changed. And the value of m is just going to be the one from the previous step. So it's going to be 20 as well. Be careful. By writing these two lines, you cannot swap the value of m and n. It's just, think about it in this way. The computer just execute each of these instructions one by one after the other one. So whenever you copy the value of n inside m, the previous value is gone. So you cannot swap the value of m and n in this way. Basically, at the end, the value of m and n, both of them are going to be the same. And both of them are going to be 20. So here, again, the D is going to be the answer of this question. Let me do another example here. You can see that here I have 3 variables. Again, I will draw a table. Let me actually use the color black. Okay. So I have a table. I have 1 column for each variable. At the beginning, you can assume that there is no value in any of them. And then you will execute the first line. The first line set a to 5. The second line set b to 3. So now you can see that the value of is going to be 5 here. The third line is going to set the value of c to 7, right? So the value of b is going to be 3 and the value of a is 5 at this moment. And the next line, you are copying the value of b inside the value of c. So the value of c is going to be whatever is the value of b from the previous step will be copied here. C is going to be 3, B hasn't been changed, and A hasn't been changed as well. Now, in this line, you are copying the value of A inside B. So, whatever is the previous value of A, it will be copied inside B. It's going to be 5. The value of C hasn't been changed, and the value of A hasn't been changed as well. Now you are copying the value of C inside A. Okay, so whatever is the value of C here will be copied inside A. So C is going to be 3. B hasn't been changed. And C hasn't been changed as well. So at the end, the value of A is going to be 3. The value of B is 5. And the value of C is 3 as well. So the correct answer is going to be E. Okay, so these are some, different set of actually instructions that I have written these examples for you to just give you this idea that how the computer actually execute the lines and how it works with the variables. One more example that I have here. This one is also actually interesting. Sometimes you wanted to, for example, just increase the whatever is the value of some variable. We can write it in this way that set for example, here the variable name for me is going to be number of students, and you are set it to number of students plus 2. What would happen if you write something like this? Again, this is going to be an expression, right? The computer will execute this expression and then copy this value inside whatever is going to be the result inside this variable. So whatever is the previous value of number of students, for example, if it is 32, the computer will add 2 to 32, so it's going to be 34. Computer can do that using the registers which are available inside the computer. Don't worry if you don't know what is a register. So when we talked about the architecture of the computers, you will learn about the registers. And then the value of 34 will be copied inside this variable number of students. So whatever is going to be the previous value of number of students, it will be actually you add the 2 to that and you will store it in the same variable again. Okay, so you can simply just write down some statement like this one. So to be able to understand that one, let me actually show you some example here as well. So what is going to be the value of C after executing this algorithm? Again, here I just care about one variable, but because you wanted to execute, you wanted to trace, to simulate the way that the computer actually executes this program, it is good that you just draw that table again, write down all of your variables here, A, B, and C. So at first, I don't know what is the value of any of these variables. Then the first line will set value of A to 15. The second line, it will set the value of B to 3. So the value of A is going to be just like before. The value of C, still I don't know. In the third line, you will set the value of C to 5. Okay, the value of B is going to be 3. The value of A is going to be 15. Here, you will set the value of C to be A plus 5. So whatever is the value of A plus 5, it will be 15 plus 5, 20 will be stored in C. So C will be 20. The value of B is going to be just like before. The value of A is going to be just like the before statement. Okay, in the last line, I am actually doing this line that is saying set C to C plus 3. So whatever is the value of C, you add 3 to that and write it down again inside C. So the value of C is going to be 23, the value of B is 3, and the value of A is 15. Actually, in this question, I just care about C, so at the end, I just need to check that whatever is the value of C, here is the answer. Okay. Okay, so here, okay, I think I forgot to actually mention these two things that when you are writing your pseudocode, you should get some input. You can see that in this, this is the example that I showed you, that just like give the value of debit to the computer, give the value of the credit to the computer. This kind of instructions will be translated in this way. It's just like giving an input to the computer. You can write them down in this way, that as get a value for define a variable for where you are going to put that information. So get a value for debit, get a value for credit. So debit and credit is going to be the name of the variables that later on we are working on that. And when you actually printing in the output, just tell them, for example, something, an instruction like this, that tell the computer to print the value, some value in the output. You can do that using some instructions like this, that print, for example, what is the value of a variable area. Okay, area is going to be the name of the variable. Or for example, print this string. Okay, so this is a phrase that you just tell the computer when I actually put something between. Usually when you are writing your pseudocode and you are actually putting something in double quotation, basically just means that it's going to be a phrase. So it's just like you are printing the message, the name is not in the directory, something like that, whatever it is. Okay, so finally the algorithm that we wrote for our previous or first simple example is going to be something like this. So let me actually clean up here a little bit. So now you can actually see that this is going to be a nice clean piece of pseudocode that if you give it to any programmer, developer, they know how to actually write down a program in terms of, for example, whatever programming language, Java, C++, Python, whatever. Okay, let's actually do more examples here. I am assume that we are going to write down a pseudocode, an algorithm that asks the user to enter a value for time in terms of seconds, and then compute how far an object would drop if it is in free fall for that length of time. We can assume that the object starts at rest and there is no friction or resistance from the air, and there is a constant acceleration of 32 feet per second squared due to gravity. So basically all of this information that we said can be summarized in this formula. From the physics, we know that if you wanted to calculate the length of the distance that an object is going to pass in free fall, it's going to, if there is no resistance from the air and the object actually starts from the rest, you can actually use this formula. This is going to be whatever is the acceleration for the gravity multiplied by whatever, the length of that time that the object is falling, power 2 divided by 2. So it's going to give you the total distance. So whatever we are going to do is that just calculating this formula. We know what is going to be the acceleration. This is going to be 32 feet per second. This is given to us. And the length of time, how long the object is going to fall, this is something that you ask from the user, okay? And then you need to calculate this the distance using this formula. We can write down a simple algorithm for this one. I will define a variable called acceleration and set it to 32. Get the value for time. I shouldn't actually put them in the quotation, but anyway, get a value for the time, and then I need to just calculate this formula. I know what is going to be the value of the acceleration. I know what is going to be the value of time, right? Because acceleration has set to 32. Time has been given, you ask it from the user and the user has entered that. Now we can actually calculate the distance. I have defined a variable. This is just, the short version of distance I have written here. So it's going to be acceleration multiplied by time multiplied by time. So instead of power 2, I have just written time multiplied by time twice, right? And then divided by 2, whatever is the result, you set it to this. And then you just need to print the value of distance, or this variable that we call it dist. Let's do one more example here. We want to write an algorithm that allows the user to enter the value for radius of a circle and in terms of centimeters, and we want to print the value of the area and perimeter for that circle. So if you have a circle with this some specific radius, we know that we know the formulas from the math, right? the area for a circle is going to be what is the value of pi multiplied by r power 2. So where pi is going to be 3.14, you can actually just use pi number is going to be 3.1415 something, right? It's but I don't know the complete actual number, so I can just simply use 3.14. And the formula for calculating perimeter for a circle is going to be pi multiplied by 2 multiplied by the radius. Actually, pi multiplied by the diameter of your circle. So it's going to be 2 multiplied by r. Okay, so I have the formulas. Now I can write down an algorithm for this. I will create a variable pi and set that value that I know for the pi. So just 4 digits precision is going to be enough for me. So 3.1415 is going to be enough. So I set pi to this value and I will get the value for radius. This is something that, when you're executing it, you will get this value from the user. And then the variable area will be set to whatever is pi multiplied by radius multiplied by radius. Right, this is going to be area. Perimeter can be calculated as pi multiplied by radius multiplied by 2. And then at the end, just print area, print perimeter. So in all of these examples, you can see that I have written a pseudocode, an algorithm. It is just a set of simple instructions. All of these instructions are something that the computer can execute. It is clear and unambiguous. And the last thing which is important about our algorithm is that the algorithm is correct. The formulas that I have written are correct. For example, if you are looking for the area of a circle, this formula is the correct formula for calculating the area. If I was actually doing something, whatever else, your algorithm is going to be wrong, right? Because you are using a wrong formula. So this is a complete pseudocode that you can actually pass, later on translate it to any programming language like Python, Java, or whatever. I have another example here that I'm not going to discuss, or we can actually just discuss the answer as well. Okay, in this example, I have asked you that to write an algorithm to ask the user to enter the length and width of a rectangle carpet, and be careful, all of these values, length and width, are going to be given in terms of feet. And we wanted to determine, for example, just assume that you are writing this pseudocode, this algorithm for a company that's making some carpet, that the users can come actually and order some carpets based on the length and the width, the size of actually the carpet. And you wanted to calculate the price that the user needs to pay. What is going to be the price to be calculated? The price is just based on this fact that each yard of the carpet is going to be $23. And I can actually give you this information that each square yard is going to be 9 square feet. Okay? So when you are calculating the area, the amount of actual carpet, the size of the carpet that will be calculated, you will get the values of length and width from the user based on feet. Okay, so if you multiply length to width, the result is going to be in terms of square feet. But you know that the price that you are paying is going to be $23 per square yard. So I need this information to convert whatever is the value of the size of the carpet in terms of a square feet, convert it to a square yard, then I can calculate the amount of money that the user needs to pay properly. So here I have a couple of steps. You need to get the information from the user, right? you need to first get the information from the user. What is the length? What is the width? And then you need to calculate the size of the carpet in terms of a square feet. Then you need to convert it in terms of a square yard, and then calculate the amount, the price that the user needs to pay. All of this can be written in these steps. Get the value of length, get the value of width, calculate the size of the carpet in terms of a square feet. I have given this name to the variable, carpet under a square under a square feet. This is the name of this variable, which is going to be the size of the carpet in terms of a square feet. It's going to be length multiplied by width, right? This is going to be a rectangle carpet. So the formula is that whatever is the length multiplied by the, so if you have a rectangle, this is the length, this is the width, the size of the rectangle, the area is going to be W multiplied by L, right? So it is going to be in terms of a square feet. You need to convert it to a square yard. Every 9 square feet is going to be 1 square yard. So if I'm going to calculate the size in terms of a square yard, I need to actually divide it by 9. So I have a new variable. This is going to be the size of the carpet in terms of a square yard. You could actually give it whatever name that you want here. Because I didn't have enough space, I just need make it actually shorter. I just read the carpet in terms of the yard. And then whatever is going to be the size, every square yard is going to be, the price of that is going to be $23, right? So whatever is the value of that multiplied by 23, this is going to be the price that needs to be paid. So you calculate the price as this value, and then you print the value of price. So in this pseudocode, you can see that I have defined a lot of different variables. Length, width, square feet, carpet square feet, and then carpet yard, and then the price. And you need to actually calculate, define all of these variables to write down your pseudocode properly. Okay, so this lecture is going to cover section 2, chapter 2, section 2. So section 2.1 and 2.2, I guess. There is a section 2.3, which is covering the conditional and iterative instructions that I will talk about them in another video.